Okay, so today's lesson is linear quadratic systems. This can be found in chapter 9-7 in your textbook. Okay, so linear quadratic systems are not much different than the systems we learned about earlier this year. A linear function is a straight line. A quadratic function is a parabola. And we're going to see where these two things cross. So before we did two linear functions, this time we're doing a linear and a quadratic at the same time. So there are three possible solutions. So in the first example here, we have a quadratic and a linear function that cross two times at -3, 0, and 5, 8. So therefore that has two solutions. In the next example, we have it where it crosses one time and at 2, -6. So since it only crosses once, it has one solution. And finally, you can have a parabola and a straight line that do not cross at all. If they don't touch, there is no solution. So these are the only possible solutions you can have: 2, 1, or none. All right, back when we first learned systems of equations, we learned three different ways: graphing, elimination, and substitution. So technically for these ones, you can do them any way you would like. I'll show you all three ways, and as long as it doesn't specifically say which method they want you to use, you can choose what method you want to use. So let's start with graphing. So for graphing, it says how many solutions does the following system have? So we have y equals x, which is a linear function, and y equals x squared, which is a quadratic, and we want to see where they cross. So I recommend using a graphing calculator. If you don't have one at home, you can go to desmos.com/calculator, and that is a graphing calculator. All right, so it's popping up here. I don't need that first one. That was from earlier today. All right. So when we're in here, we're going to go ahead and type in our equation. Now, you don't have to type in the y equals part, just the side, right side of the equation. So you can either type using your keyboard, or you can use the keyboard here on the screen. So our first equation was y equals x, so I could put x in and hit enter. And the second one was x squared. So I'm going to hit x, and then I'm going to use the a squared button to give me my exponent. So you can see I have a parabola and a linear function. If I click on the spots where they connect, the ordered pairs will stay on the screen. So this one has two solutions at 0, 0, and 1, 1. So let's go back to our slide. So this one, how many solutions? There are two solutions. We said 0, 0, and 1, 1. Okay, example 2 is the same thing, but you notice it's set up a little bit different. So this time we have two pieces. We have this part equals this part, and they're all in one line. What we need to do first is we need to separate them and set them equal to y. So I can say y equals 5 minus x squared. And I can say y equals x plus 3. Okay, and then I can graph those two new equations. Now, if it bothers you that the first one is not in standard form, it's not going from the x squared down to the constant, you can flip it the other way. You can make it negative x squared plus 5. It doesn't matter. All right, so let's go back to Desmos. Nope, I don't need a new one. Okay, and we're going to go ahead and clear out what's in here and put in our new functions. So our functions were 5 minus x squared and x plus 3. All right, so I can see again my problem, my straight line, they cross twice. And if I click on them, those are my two solutions. So again, let me go back. We have two solutions. And our solutions are -2, 1, and it was 1, 4. So pretty easy. Okay, so at this point, I want you to try these two. They're both set up like the one we just did. You can go to desmos.com/calculator and try on your own. I suggest pausing the video and then coming back and see if your answers are correct. Okay, hopefully you paused the video and you're back now looking for the answers. So if we set these two pieces equal to y, we have y equals x squared plus 1 and y equals x plus 3. If you put those into Desmos, you should have gotten two solutions. Okay, and the answers are -1, 2 and 2, 5. Okay, second one, you're going to do the same thing. Y equals 5 minus 0.5 x squared, and y equals -0.5 x plus 2. If you put those into Desmos or graphing calculator, you also got two solutions. We had -2, 3, and 3, 0.5. Okay, so you're not always going to have two solutions. You could have one or no solutions at all. These ones happen to all have two solutions. Okay, so in example 3, this is the one from your textbook. This is elimination. So you notice mine is set up a little bit different. I spaced it out a little bit compared to what's in the textbook. And the reason is our very first step, if you look on the right, says subtract like terms. So I wanted my like terms to line up vertically. So if you're writing these on a piece of paper, you could also line them up vertically. So the first one says subtract like terms. So we're going to turn this into a big subtraction problem. And we're just going to subtract straight up and down. So y minus y is 0. They cancel each other out. X squared minus, there's nothing here, so that's like saying 0x squared. So 1x squared minus 0x squared is still 1x squared. Okay, -6x minus positive 2x. That is -8x. And then 8 minus -4. Be very careful when you have a positive minus a negative. The negatives cancel out, and technically you're adding. So 8 plus 4 gives me 12. Okay, so subtracting like terms, done. Now we need to factor. So if I'm looking at the right-hand side, I see that it starts with x squared. There's 3 terms. So that is set up well for factoring by using the diamond method. Ha, you guys thought the factoring stuff was going to go away, and it hasn't. So to factor using the diamond method, I have to say to myself, what's going to multiply to the last term, which is 12, and what's going to add to my middle term, which is 8? So take a second, think about that while I set up my parentheses here. All right, multiply 12, add to -8. You should have gotten -6 and -2. All right, -6 times -2 is 12. -6 plus -2 gives me -8. So I can go ahead and put -6 and -2 in my parentheses here, and I still have my equals 0. So factoring is done. Now remember, factoring could appear in different forms, so you may have to use the GCF, you may have to use the illegal move, you might have to do the diamond method, any of the ones we talked about, difference of squares, perfect square trinomials, those type of things. So definitely take a look at your factoring notes if you are getting stuck on the factoring steps. Okay, next says zero product property. So this was a topic from the very first week of our distance learning. So if you're not sure what the zero product property is, I would go back to, I think it's in week 1, and look at some of the materials that are there, or you can go back in your book and look up zero product property. But basically, if we are multiplying two things together like we are on the right side of our equation, and the answer equals 0, that means that one or both of those need to equal 0. So what we're going to do is we're going to take each of our two pieces and we're going to set them equal to 0. So I'm going to say x minus 6 equals 0 and x minus 2 equals 0. All right, so if we go ahead and we solve for x for both, I can add 6 to both sides and I get x equals 6. And if I add 2 to both sides, I get x equals 2. So that's fine. I have my x values. I did my zero product property, but now I need y values. So to find the y values, we're going to use substitution. Okay, so what I do is I go back to the linear function. The linear function is the one that does not have the x squared. So I'm going to use my linear function, and I'm going to substitute 6 and 2 into that equation to find my y's. So if I substitute 6 first, I say y equals 2 times 6 minus 4, the original, right? 2 times 6 is 12. 12 minus 4 gives me 8. Oops, sorry about that. That's a crazy 8. Let's try again. There you go. All right, so if my x was 6, my y is 8, my ordered pair would be 6, 8. And then over here, I'm going to do the same thing. So y equals 2 times 2 minus 4. Well, 2 times 2 is 4 minus 4. So y is equal to 0. So my ordered pair would be 2, 0. So 6, 8, and 2, 0 are my solutions. Okay, so here's another try it using the elimination method. If you look on the screen, I've already set them up vertically for you. I would be careful with this one because remember, those blank spaces are zeros. So keep that in mind while you're trying it on your own. Go ahead and pause the video at this point and come back and check the answers. All right, welcome back. So if you're looking at this one, we have to set it up like a subtraction problem. Y minus y is 0. And remember, I told you there's a 0 here, 0x squared. So if I have 0x squared and I take away 1x squared, 0 minus 1 gives me negative 1x squared. Be careful. A lot of people will put positive x squared there, but it's really a negative. And then same thing in the next one. I have negative 1x minus 0x. Negative 1 minus 0 is still negative 1x. And then 4 minus negative 2. So again, I have minus a negative, so that's technically adding, is going to be 6. So we have subtracted our like terms. Now we need to factor. Now this one's a little bit different because I see that I have 3 terms. I see that I have x squared, but I notice how I have that negative in my first term. So the very first thing I need to do is I need to factor the negative out. So that's like taking a negative 1 out of my equation here. So if I divide everything by negative 1, I'm going to put what's left in the parentheses. So negative x squared divided by negative 1 is x squared. Negative x divided by negative 1 is positive x. And 6 divided by negative 1 is negative 6. And I still have my equal 0. I'm going to put it on this side just because I ran out of room. It doesn't matter what side the 0 goes on. So factoring is done because there's nothing else. If I look at the middle terms there, there's nothing that's going to multiply to negative 6 but add to 1. Oh, I'm sorry. No, we do have to factor. Sorry. Whew, getting ahead of myself here. We do. We have to factor this further. There is something that multiplies to negative 6 and adds to 1. Sorry, guys. It's really early in the morning. So, all right. So remember, if you're adding to a 1, that means that our numbers have to be consecutive on the number line. So what 2 numbers, just think of it as a positive 6. What 2 numbers are side by side on the number line that multiply to 6? Well, that's 2 and 3. And then now I have to multiply to a negative but add to a positive. The only way that can happen is if our smaller number is negative, because negative 2 plus 3 will give us positive 1. So now I can take those 2 numbers and I can write them in factored form. I'm going to keep my negative on the outside. So I have x minus 2 and x plus 3. All right, so we can do the zero product property. That negative is kind of dead. It's out front. We can't do anything with it. But we can do the zero product property with what's inside parentheses. Okay, so I can set those 2 pieces equal to 0. Now, I'm sure many of you figured out when you did the zero product property, if it's set up in simple like this, a one-step equation, it's just the opposite sign. So this one would be x equals 2. And this would be x equals negative 3. Okay, it's only when it's a two-step equation or more that the answers might be different, but if it's a one-step, just change the sign. All right, so now that we have our x values, let's go get our y values. So let me change colors here. I'm going to go up and find my linear equation. My linear equation is my first one. And we're going to substitute 2 and negative 3 in. So the first one, we have y equals negative, and my x value is 2 plus 4. Well, that's like saying negative 2 plus 4, which is 2. So that order pair would be 2, 2. And the second one, I have y equals negative 3 plus 4. Don't forget the negative in front because that's in the equation. So negative 3, that means the opposite of negative 3, which is positive 3. Whoops, plus 4 is 7. So my answer is negative 3, 7. So I have two solutions, 2, 2, and negative 3, 7. All right, here is another try it. So go ahead and pause your video, give this one a shot, come back and check your answer. All right, so this one bugs me a little bit because if you look at the second one, it's not in order. So the constant is not the end. And the numbers really don't line up with the one above it. So what I'm going to do is I'm going to copy the first one over again. Okay, and then the second one, I'm going to rewrite it so that way they're in order. So the x I want to come before the 2, but the x is negative, so it's going to be negative x. And the 2 is positive because there's nothing in front of it, so it's technically a positive 2. So the equation negative x plus 2 is the same as 2 minus x. I just rearranged the terms. And now we're going to go ahead and subtract our like terms. So subtract everything. Y minus y is 0. And then negative x squared minus nothing is negative x squared. 4x minus negative x, so that's minus minus again. 4 minus negative 1x is 5x. And then 2 minus 2 is 0. So we can go ahead and just leave that alone. You don't have to do anything with it because those two terms are going to cancel out. Okay, so subtracting like terms is done. Now we need to factor. So looking at the right-hand side, this one would not be good for diamond method because I don't have 3 terms. I only have 2 terms. So I need to think of a different way that I could factor this. I mean, technically I have a plus 0 in the end, but there's nothing that's going to multiply to 0 and add to 5. That's impossible. So I'm going to see if I have any like terms. So I notice they both have x's. So I'm going to go ahead and factor out an x. So I'm going to take an x out to the front. And if I divide both pieces by x, I'm going to see what's left. So negative x squared divided by x is negative x. 5x divided by x gives me positive 5. And I still have that equal 0 on the front. Okay, so I factored out a greatest common factor. There's nothing else that I can do with this, so I'm done. So now let's go to zero product property. So this one's a little bit different because we have the x in the front. So we can take the x piece and set it equal to 0. So x equals 0 is one possible solution. And then we take what's in parentheses, negative x plus 5, and set it equal to 0. So let's go ahead and solve for x. So I can subtract 5 from both sides. So negative x equals negative 5. But to get rid of that negative sign in front, I have to divide by negative 1. So I end up with x equals positive 5. All right. So I've done my zero product property. Now I need to substitute to find my y values. All right, so again, I go to my linear equation. My linear equation does not have an x squared, so it's this one right here. It's a little bit shorter and simpler. And I'm going to substitute 0 and 5 in. So first I'm going to do y equals 2 minus 0. Well, 2 minus 0 is 2. So the first order pair is 0, 2. And then if I do the 5, I have y equals 2 minus 5, which is -3. So 5, -3 is my next one. So again, 2 solutions. Now, if you wanted to double check, you have a couple options. You could substitute the x values back into one of the equations and you should get the y value. Or you could take these two equations and graph them and see if you get the same solution. So you have some choices on how to check to see if you're right. All right, the next method is substitution, and they give us this real life example with 2 phone companies that are launching phones. And they want to know during what week are the sales projected to be the same for both phones. Okay, so they want to see when are the 2 phone plans going to be equal to each other. So what we're going to do is we are going to take these 2, I'm just going to rewrite them over here. Let's see, we have y equals -2x squared plus 60x. And then the second one is y equals 20x. Now I could do elimination like I did before. That's fine. I could line up the 60x and the 20x and subtract and do all that. But this time I'm going to use substitution. So substitution is when you replace one of your variables. So one of your variables go away. So since they both say y equals, I'm going to set the first one equal to the second one. So I'm going to take that -2x squared equals 60 and I'm going to put it in place of the y in the second one. So we would have -2x squared plus 60x equals 20x. So see how there's no more y's now. I just took the 2 pieces, set them equal to each other. It kind of looks like the second example that we did for graphing when you had 2 pieces equal to each other. Okay. And then now we're going to solve for x. So in order to do this, the one side has to say equals 0. So my general rule of thumb is wherever x squared is, that's where everything needs to be on that side. So since our x squared is on the left, we're going to take this 20x and we're going to move it over to the left. So 20x is positive, so I'm going to subtract 20x. Okay. And in looking at this, I know 20x and 20x cancel out, so I have equals 0. And then you have to ask yourself, what is the like term of 20x? So in this case, 60x and 20x are like terms. So I get to keep -2x squared, but I can do 60 minus 20. That's 40x. Okay. All right, so now I can factor. So I've substituted, now I'm factoring. And looking at this, I noticed that they both have a 2. Like I can divide them both by 2. And since my first term is negative, I'm actually going to divide it by -2. So I'm going to pull out a -2x because that's the GCF, the greatest common factor of those 2 terms. Okay, so if you remember, we can divide both of these by -2x to get what's going to be on the inside. So -2x squared divided by -2x is just x. And then 40 divided by -2x, the x's are going to cancel out, so you end up with -20. Okay, and then you still have your equal 0. Well, now we can do the zero product property, the same thing we did in the last one. So I'm going to take the 2 pieces and I'm going to set them equal to 0. So I can say, I'm just going to write over here, I can say -2x equals 0, because that's my first piece here. And then I'm going to take my second piece, x minus 20 equals 0. Okay, if I go ahead and I divide both sides by -2, I get x equals 0 still. And then if I take this side and add 20 to both sides, I get x equals 20. Okay, well in this case, real quick, we can think about this logically. X stands for weeks. Okay, we can see that in the problem up top. Does it make sense that the 2 phones will have the same sales in week 0? No. So I'm just going to get rid of that one altogether. It just does not make sense in this problem. So we definitely know at 20 weeks, these two phone sales are going to be the same. But now we have to figure out how much money are they going to make? What is the sales going to be? So just like before, I'm going to take that 20 and I'm going to substitute it into one of my equations. I'm going to pick the linear one just because it's a lot shorter. I'm going to pick this y equals 20x. So if I go through y equals 20 times 20, I know it's 400. And in this case, they're talking about thousands because look, it says projected sales in thousands on both of them. So really, the projected sales is 400,000. And that is at week 20. Okay. So you can use substitution. A lot of the steps are similar, whether you do elimination or substitution. It's completely up to you. Just make sure that you always solve for your x value and your y value. All right, so this week's classwork, or this lesson's classwork, is page 400 and 401. You have two sets of problems to do for that. These ones are pretty quick, especially the first couple of them. And then the exit ticket is page 401, numbers 27 and 28. Please make sure that you are turning those into me so I can record your answers and give you feedback. You can do that through Schoology. Type right into the problem. You can do them on a piece of paper and submit them via email or through the drive. You can type it in a Word document. It does not matter as long as you get that to me.